which is the first machine that could produce sort of continuous static electricity in the 19th century for developing electrical science. And basically there's two discs that spin round in opposite directions, and they split the uncharged electricity up into two polarities, negative and positive. One collects on one of the spheres and the other negative collects on the other. When the voltage gets up, in this case to 50,000 volts, it will jump over the spark gap, and you get a sort of narrow spark which is similar to lightning.
Right.
Yeah, that's 50,000 volts, so you know how long lightning strikes are, so you're talking about millions of volts there.
Wow.
So if you got to cross this, it would give you a belt, but it wouldn't finish you off.
Oh.
But lightning's another matter altogether. So, and that was used at the end of the 19th century when they discovered X-rays, and they made an X-ray tube. The only way to get the high voltage to run the X-ray tube was using Wimshurst machines. And that was used sort of around the turn of the century. I'm afraid we can't run that today, but just to show you what it is. This one is basically current electricity. It's mains electricity that's transformed up to 50,000 volts by the box. So that's a transformer, high power transformer. And so it's 50,000 volts. If you've got to cross that, that would be turbine. And the gap at the bottom of the tube, the two tubes, is designed to break down immediately with the 50,000 volts. That causes a discharge, which is called an arc, because it's much more intense than the Wimshurst machine would produce. And because it's an arc and it's got a lot of power, hot air rises, so it takes the arc with it. It goes up to the top, and when it diverges, it gets to the point where it can't break down the air molecules anymore, and so it dies and starts again.
Oh!
You might have seen these in horror films and Frankenstein movies. You can see it's not going into the straight line. It follows what seems the best electrical path to follow. You see, when it gets to the top, it's about to die. You tend to get a thinner spark.
Yeah. It's more like a flame.
That's right. This is used. This is known as the Tesla coil. It was invented by Nikola Tesla, who was an East European electrical engineer in the 19th and early 20th century. He worked for Thomas Edison and George Westinghouse on the development of power transmission systems. And Tesla came up with the AC distribution system that's used all around the world, where you generate power in the generators in the power stations at medium high voltage. You transform it up to very high voltage, in our case 400,000 volts, because if you do that, you have higher voltage but lower current, therefore you lose less of your power in losses in the cables. So that's why you want to transmit at the highest voltage as you can, to not waste power and heating the atmosphere up. Well, he worked for them, but he didn't make the money. They all made the money, and he died in poverty. And but he had this idea of transmitting power without wires, and he had backers for this. But when they found out you couldn't meter it, because it was effectively a radio transmitter, and so anyone could pick it up and use the power. Also, if you were going to do it for real in the modern world, you needed such high density of the power field for to be able to distribute to everybody. You'd effectively be living in a low frequency version of a microwave oven, which would sort of tend to cook you. And you know how sort of neurotic people get about mobile phones. Well, this would put out vast amounts of megawatts, and you'd generally be heated up too much. So not a good idea for that point of view. But the other thing about it is, essentially, it's a radio transmitter. It's tuned, in fact, at about the same frequency as Radio 4 on the long wave, and although it's screened, it doesn't get out and interfere. So that was the same principle. Marconi's original transmitters, where he crossed the Atlantic and up to the First World War, all radio transmitters were based on the same principles as this. and it's basically a tuned circuit where you tune a radio, different stations. This is tuned to Radio 4, just coincidentally, but it enable you to pick out different signals. But again, because it's a spark transmitter, it tends to spread a lot of extra signals around, so you can't have many stations. They have to be very widely spread in frequency. And it was only when in the First World War about the thermionic valve was invented, you could make it much better and create the radio frequency by different electronic means, and it was much more controllable, and you could have narrower gaps between all the stations.
Does it contain the spark then or something?
Well, the spark is a sort of makes lots of frequencies. It's not, although it goes into this and it makes it narrower on one frequency, there's still a load of rubbish wasted all around the side, which with any stations near it would interfere, and you'd get all this rubbish, like a sort of sparking going on all the time, crackling.
Yes, okay.
So, anyway, this thing produces 500,000 volts of RF.